All right, another way to represent data is with a pie or circle chart. These ones are pretty common. I'm sure you've seen them before, if not in real life, on assessments through your school, through your schooling. But a pie or circle chart is best used when you're trying to compare a part to a whole. So when I say those words, a part to a whole, maybe a fraction comes into your mind, or a percentage is used a lot for circle charts. So here's an example of a circle chart where we have a table where it looks like it's some kind of poll, and four people prefer a comedy. That's their favorite type of movie. Five people prefer action, six romance, one drama, and four sci-fi. So questions that you'll get on your IXL homework will be things like which category is the highest, right? Which had the highest amount of people to vote for it. We can see here just even the biggest piece represented is the biggest, right? Whereas the smallest here would be drama. So some of your questions will relate just to that. And also, I have a couple sample questions coming up, but some might ask us specific information about a percentage of a number. So I'm just going to make one up here. But let's say that 20, no, let's say that, 20 people were polled. No, yeah, 20 people were polled. How many prefer comedy? Okay, so I see it says 4 here, and I want to kind of, let me see how many are here. Well, it would be 4, but say we didn't know the numbers, okay? Say we didn't know these numbers, and it just gave us the percentages. All right, so stick with me here. Just say they said comedy was 20%. We didn't know any of this information. Well, some of you, I know you haven't been with me with percents. So that's why I'm going over it now for the sake of this lesson. But when you're taking a percentage of a number, you multiply the percent by the number. So we're taking 20% times 20 people to find how many people are in this bucket, right, of comedy. And 20% as a decimal, I want you to think like 20 cents. So it'll be like that, 0.20 times 20. And if I did the math and brought up our calculator, it would give us 4 people, which we see here is 4 people. But taking a percentage of a number, you always multiply the two. Feel free to use your calculator when you're working through these. But just for kicks, let's do drama here. So 5% of 20 people would be 5 cents times our 20. And that would just give us one person. 5% to 20, if we did that on a calculator, would give us one person prefers drama. And so on. We could do the whole chart. Okay. And also, you could have a fraction. So say instead of percentages, it gave us a fraction of like 1/4 for action. It's the same idea. You would take your 1/4 times 20, and if you type that in the calculator, you would get 5. So whether it's a percentage or a fraction, when you're trying to find that piece of the puzzle, like how much each category will be, or a specific category the question's asking, it will be to multiply those two. Another type of question you may see on your Circles IXL lesson is a question about the measure of central angle. So here it says an online music retailer generated an internal report about how many songs in each genre were sold last year. So online music sales, 47% were pop, and of those online music sales, 53% were classical. Then the question reads, what is the measure of the central angle of the pop section? So basically, this kind of goes off our lesson last week, but basically it's saying, hey, what's this angle? From like here to here, how big is this angle? All right, that's really bad drawing. I'll use my pen. But what is this angle? I'm doing that side of it because it's specifically talking about pop, the pop section, so that's why I'm here. So from last week, if you guys recall, a straight line, if I went from here to here, is 180, right? So this almost opens up to 180. So we know our answer is close to 180, but a way we can be sure, like to do the math of it, is if a line from here to here is 180, then two of them, if I kept going this way, a full circle has 360 degrees. So you might want to take a note of that. A full circle has 360 degrees in it. If I want to know what 47%, what that angle measure would be, I would take 47% of 360 of that whole circle. Remember, 47% is like 47 cents times 360. I'm just going to use my phone here. But if you type that in, 47% of 360 gives us 100. Well, let's see. 360 times 47%. Yeah, it gives us 169.2 degrees. And since this doesn't ask us to round anything, this is our final answer. So 169.2. So if you get a, not if, when you get a question about central angle of a circle graph, you take that percentage they're referring to and you times it by 360. So just for kicks, if we wanted to do the classical one here, we would take 53%, so 0.53 times 360. And if I do that, we get 190.8. Right? So depending on which category it asks for. But you better believe that this piece here plus this piece is this whole circle, right? From here to here is 180 and 180. So same idea here. Let's do another one here. So Stefan recently emptied his coin jar and counted the coins. So 48.5% are silver, 51.5% are gold. What is the measure of the central angle in the silver coin section? This is what I care about. Right? So I want to know what 48.5% of 360 is. So this as a 48.5 as a decimal will be 0.485. That's as if you're moving your decimal 2 spots to the left is really what you're doing there. And then the of, remember, becomes times, and then our 360. So again, I'm just going to use my phone quickly here. So 0.485 times 360, and we get 174.6 degrees. So again, it doesn't ask us to round it or anything, so we're just going to keep it at that. Next up, we have a stem and leaf plot. This is not used often in the media or real world, but it is used a lot in math. Okay, so here a stem and leaf plot is a special table where each value is split into a stem, the first digit, and then a leaf is the last digit. So typically you would see something like this also. So it looks kind of more like a table. We'll look at example problems here in a minute. But in this case, the stem you want to think of as our tens place value, and the leaves as our ones. Right? So for example, and we'll go through all of them here, but this 1 and this 5 represent 15. Right? 1 and 5 represent 15. The 1 and the 6 represent 16. Right? The 2 and the 1 represent 21. The 2 and the 3 represent 23. The 2 and another 3 represent another 23. And so on. 2 with 2 sixes would be 26 and 26. 33 and the 0. 32, and kind of that's the example they shared. And then 41, 4 and the 1 here for 41. So I added this to your packet so you don't have this in front of you, but I want to go through just a couple type of questions and how they'll be asked on the stem and leaf plot lesson. So here the Middletown Soup Company recorded the number of rotten tomatoes in each barrel it received. So it looks like we have, and I'm going to painfully type these out so we can see them. So we have 24, 29, 32, 33, 35, 35, 35, 36, 38. Keep going. 43, 43, 7, 48, 54, 62, 63, 63, 67, 73, 79, 85, and 88. So you can see how long that really took me to type all those out. So a stem and leaf plot just shows it quickly, right? That's all it is. It's just a way to show data more quickly than typing them all out or writing them all out. So here our question reads, how many barrels had at least 80 rotten tomatoes but less than 90? So at least 80 but less than 90. So at least 80 would include 85 and 88, and we don't even have any in the 90s range. So there were only 2 barrels that had at least 80, right? More than 80, but less than 90 rotten tomatoes. So it's just 2 barrels here. So you don't have to write out the numbers like I did here every single time. You surely don't have to do that. But it does just I just wanted to show how that looks. You could also see the numbers right in here. So 79 is not at least 80. So here we have 85 and then the 88. So we have 2 barrels. Let's look at another one. Again, this isn't in your packet. This is just me going over some questions. So a pottery factory kept track of the number of broken plates per shipment last week. So broken plates per shipment. So notice here how I have a 70 in the stem column. This would be written as 707. Let's keep going down the list. The next one would be 710. And 725. Hard to keep them. I'm not going to be able to quite line them up, but 725, 735. There's no 740, so there's no numbers there. Then we have 753, 753, 753, 753, and 759. Let's move my list over here. Maybe make it a little bit smaller. So this is just this list represented right here. The question reads, how many shipments had exactly 753 broken pieces? We have 1, 2, 3, 4. Right, so 4 shipments would be our answer here. So again, you don't have to write your list. You could find them right here in your stem and leaf plot. 1, 2, 3, 4. But if this helps you see the data better, that's what I'd like you to do. All right, let's see here. Last one for stem and leaf plots here. So for a social studies project, Oliver counted the number of classrooms in each school in the city. So one school just had 9 classrooms. Another school had 10. Another school had 16, 19, and so on. What is the smallest number? So the smallest number listed here is 9. If the stem is 0, this just represents 9. Just a plain old 9. So it could also ask you what's the largest, right? That would be 58. It's just depending on the question you get. So there is a bunch of information about circle graphs and stem and leaf plots.